All right, our next concept here for Algebra 2 is polynomial operations. So we're going to be looking at adding and subtracting and multiplying polynomials. Um, we are going to take a look at division later. That's going to be a separate topic, a little more tricky than these first ones. So first thing we're going to look at is when we have to add two polynomials. Here's an example of two polynomials. The only reason the parentheses are there is just to separate the two polynomials. So here's my first polynomial plus this polynomial. And it's pretty straightforward. We just need to make sure that we're putting our like terms together. So it comes back to that stuff you learned back in Algebra 1 and in junior high. And we just got to put those things together. So a couple different ways you can do it. Some people are just okay with just going in a line like this and saying, hey, I've got x to the 6 plus 3x to the 6. It's got the same variable, same exponent. I've got like terms. And then they're just able to write down their solution. Another way that I've found easier and might help you line up your correct terms is to kind of stack them on top of each other. So I'm going to go x to the 6th plus 3x to the 5th. And I'm going to leave a little bit of a gap if I need to. And this one I don't have to because they match up perfectly. And I'm just going to put my like terms together. You know, had I had a term that had a third power or a fourth power or just a first power, I would have left a gap there and you know, not put it together with anything because it isn't a like term. So since I can add these, remember that we do not add the exponents. The exponents stay the same when we're adding. We just add the coefficients on those terms. So I've got 3x to the 6th power plus 1x to the 6th power. So really I've got 4x to the 6th. So I just add the coefficients. I don't do anything with the exponents. Those exponents tell me what my like terms are. Now I've got my x to the 5th terms. I've got 3x to the 5th minus 1x to the 5th. So I've really got a plus 2x to the 5th. Then I've got a negative 3x squared and a negative 4x squared, which gives me a negative 7x squared. And then I've got an 8 and a 7. My constant terms will go together. Those are like terms, plus 15. It is usually the correct way to finish in standard form, and so my terms are in order by their exponents. Okay, pretty straightforward. Nothing too crazy about that. Just make sure you have your like terms together. We can't put anything that aren't like terms. So if these were all y's, I would not be able to add any of those things other than the constants. So adding, pretty straightforward. I think that shouldn't be an issue. The next one, subtraction, can sure be a little confusing. We just got to be very careful. So when I look at this, I have my whole first polynomial minus this second polynomial. And if you notice, there's a lot more terms in this first polynomial than there is in this trinomial. And so we're going to be subtracting each piece. The most common mistake is people will subtract the 2x cubed here, and they forget to subtract the x squared and subtract the negative 7. So a way to remember that and to make it a little easier to work with is I like to think of this as a negative 1, and I'm just going to distribute that into that second piece so that I know that I'm subtracting each piece. So really I've got a negative 2x cubed minus x squared plus 7. So really that's what I'm looking at with that second term. Now I can stack that on top of each other and work with that just like I did with the addition and make it a little bit easier. So I've got 3x to the 4th minus 3x to the 3rd. I'm just rewriting this first polynomial. And I'm going to go ahead and put my like terms underneath. So notice that I don't have an x to the 4th, so I'm not going to put anything there, but I did have a minus 2x cubed. So I'm going to put that with my other x cubed term. I want to make sure I line up my like terms. Then I did have an x squared. It was a minus x squared because I was subtracting that x squared. That is the biggest mistake, is not taking that negative through every piece. And then I had a plus 7. So I don't have an x term, but I do have a constant term. So notice how there's some missing gaps that I just left open. So really I'm not going to add anything to those. So I just bring down my 3x to the 4th. Then I've got a negative 3x cubed minus 2x cubed, which gives me minus 5x cubed. Then I've got 2x squared minus 1x squared, so just plus 1x squared, or just plus x squared. I've got nothing that goes with the 5x, so I just leave it as is. And then 3 plus 7 is 10. Very similar to my addition, but we've got to make sure we subtract each piece. I find the stacking them is a lot easier when you're trying to put the like terms together. So not too bad. Adding, subtracting, things that you guys have probably done pretty well. Our last piece here is just multiplication. Sorry, I got a little ahead of myself here. We're going to start by multiplying two monomials. And so when I take 3x squared times 7x cubed, this is all multiplication. This is really just like 3 times x squared times 7 times x cubed. And I can use the commutative property to move everything around, right? So really I could say, hey, 3 times 7 times x squared times x cubed. The number part's easy. 3 times 7 is 21. That's pretty straightforward. I can just go and say, hey, 3 times 7, 21. I know my coefficient is going to be 21. But it's our exponent properties that you got to bring back from Algebra 1 that may trip you up. So x squared times x cubed is a product of two powers. They have the same base. They both have x as their base. When I multiply those out, that's really like saying x times x, that's my x squared, times x times x times x, that's my x cubed. If that makes sense. So how many x's do I have multiplied by each other? 1, 2, 3, 4, 5. So really I have x to the 5th. So the property then for those exponents is I can just add the exponents when they have the same base. So when I'm multiplying two powers, I'm just adding the 2 and the 3, the exponents, to get my new exponent. Okay? So if I go back to the top there, pretty straightforward. 3 times 7, 21. X squared times x cubed, add my exponents because I'm multiplying, I end up with x to the 5th. So you'll be asked to multiply some monomials together. Here's an example of a monomial, a one-termed polynomial, times a binomial, 2 terms. And really all we're doing is using the distributive property. So 3x times 2x squared. The 3 times the 2 is a 6. I can just multiply my coefficients together. This x has a power of 1. 1 plus 2 is x to the 3rd. Remember, I'm adding my exponents. Then I take 3x times 7. 3 times 7 is 21. And then I just have an x. Pretty straightforward. I'm not asking too much of you. And then you may see a monomial times a trinomial. And basically it's all the same. So I'm using distributive property. Now I'm just going into 3 terms rather than in 2. Negative 4 times 2 is going to give me a negative 8. X to the 3rd times x squared is x to the 5th. I add my exponents. Okay, then I go ahead and go back. Negative 4x cubed times negative x gives me a positive 4x to the 4th. This has a power of 1. And then my last term, negative 4x cubed times positive 5, would give me a negative value, minus 20x. So this concept, you are adding, subtracting, and multiplying polynomials.